Hare Krishna. So, welcome to this session on number system, where first part of this number system we had discussed in the last class. I hope you have seen my first video of this number system, and if you have not seen, please see that video first, which is number system session 1. And here in this is for number system session 2. We are doing a quick recap of what we have done in the session 1. See what is written here on the screen. We have to cover in number system, the complete number system. And in session 1, we have covered these things. We have covered number system. We have covered whole numbers. We have covered integers, and these things actually we have discussed in session 1 also, that number system, whole numbers, integers, that you must have read earlier also in earlier classes. Nothing new in this session, in this class. And we had done rational number also. Please go through the rational number very clearly, need to be very clear, as the next we have to cover in this session is the irrational number. To understand the irrational number, it is very important that you understand rational number first very clearly. There should not be any doubt. See, in my intro class itself, I have told all the students, whoever is watching my video, that see, everything what you are studying, whatever you are going through in mathematics, need to be very clear in your mind. Like, you should not go to session 2 until your session 1 topic is very clear in your mind. So go through session 1, read your book also. Whatever book we have, you can read NCERT book, and you can read other books also, your textbook. So in this class, we would start with irrational number, right? We would start with irrational number. So we are starting with irrational number. See, in session 1, we have already done the rational number. So to understand, see, irrational number, we need to know what is the rational number. So we will do a quick recap of what is rational number, and then we can only understand what is irrational number. So let us see what is rational number, what we have seen in session 1 about rational number. See, what we had seen as rational number, the number which are in the form of or which can be represented in the form of. In session 1 itself, I have told that this line is very important, which is in the which actually the definition says which can be represented in the form of p by q. So it may be the number itself is in the form of p by q, or if it is not in the form of p by q, we have to see that whether the number can be represented in the form of p by q, right? That need to be important, which can be represented in the form of p by q, which can be. So where p and q are integers and q is not is equal to 0. This is what we had seen as rational number, the number which can be represented in the form of p by q, where p and q are integers and q is not is equal to 0, are rational number. For this session, our topic is irrational number. So rational, irrational. By the term itself, you can identify that rational, irrational. Irrational means what? The number which is not rational are irrational. Very simple. Which are not rational are what? Irrational number. So of course this simple definition we cannot write, but yes, the rational number is this only, which cannot be represented, which are not rational number. So if we apply the negative of rational number here, so what we can say about irrational number? the number which cannot be. The rational number definition says the number which can be represented in the form of. So the definition of irrational number should be the number which cannot be represented in the form of P by Q. So what should be the definition here? The number which cannot be represented in the form of P by represented in the form of. Again, see, the important is what? Which cannot be represented in the form of P by Q. Need to be remembered. See, rational, irrational are same, like they are related. If you understand rational number, you would understand irrational number also. Or if you understand irrational number, you would understand rational number also. Because you know what is rational number, that means you know which are not rational number, so those are irrational number also. If you cannot identify which are not rational number, that means rational number is not very clear to you also. So here the number which cannot be represented in the form of P by Q, where P and Q are integers and Q is not equal to 0. Clear? The number which can never be represented in the form of P by Q, where P and Q are integers and Q is not equal to 0. Right? So let's see some examples that which number are irrational number and which cannot be represented in the form of P by Q. See, there are many examples. You need to understand them very clearly. There are many examples. See, the most easy example is the square root of, like square root of 2. This can be 3. 4. No, 4 cannot be, because 4 is nothing but 2, which is a rational number, because 2 is nothing but 2 by 1, which is rational number in the form of P by Q. Then we can write 5, you can write 6, like this you can write. Again, you cannot write square root of 9, because this is nothing but an integer itself, which is 3, so which is in the form of P by Q. And these numbers are irrational number. Again, why these numbers are irrational number? Let's see one of these examples. Like we take root 2. If you try to find out the value of root 2, the value of, or in the exam also, in the question itself, sometimes you will find out that it is given in the question that take the value of root 2 as 1.414, and it is also sometimes written pi, and take the value of pi as what, 22 by 7, or it is sometimes written that take the value of pi as 3.14. So please remember, these are not the exact value. These are only an approximation, not exact value. So when we try to find out the exact value of root 2, this is 1.414 and continuing. This is not ending here only. You can find it through your calculator or in your computer. You can push the value of root 2. Let's see. And you can see that what the value comes out, what the value pops out. So it will be the value of root 2 will be coming as 1.414, and this decimal representation will be non-terminating, means it would never end, non-terminating. Okay, the decimal representation will be non-terminating. So one more definition comes here for irrational number, that the decimal representation of an irrational number is non-terminating and non-repeating. Right? The decimal representation of an irrational number is non-terminating and non-repeating. Like the digits of this decimal part would not repeat, means a pattern would not come, so you cannot guess the next number without doing the actual division. So the decimal representation of an irrational number is non-terminating and non-repeating. You can see your book. Somewhere in the book must be given the non-terminating and non-repeating value of one of the irrational number up to certain number of digits. Of course, we cannot give the complete decimal representation of an irrational number because it is non-terminating. It would never end. Right? So please remember that the decimal representation of an irrational number is non-terminating and non-repeating. So if we say, when we say that the decimal representation of an irrational number is non-terminating and non-repeating for irrational number, this is for what kind of numbers? This is for irrational number, right? So what it should be? What it should be for the rational number? If we take the opposite of this, means what should be there for the rational number? How should be the decimal representation of a rational number? यदि हम इसका उल्टा करें, then what we would find? Either it is either it is terminating, either please either terminating, or if it is non-terminating, if the decimal representation is non-terminating, then it should be repeating. See, either it is non-terminating, or if either it should be terminating, or if non-terminating, if it is non-terminating, then what? Then it should be repeating kind of thing, means a pattern would repeat. A pattern of 1 digit, 2 digit, 3 digit, or certain number of digits would repeat itself. So you can identify what digit would come next without doing the division. After a certain number of digits, after writing a certain number of digits, you can identify what would be the next digit. Why? Because the digits are repeating. A pattern, a group of digits are repeating itself in case of rational number. But in case of irrational number, it is non-terminating as well as non-repeating. Clear? Okay. Let's see some of the examples. As we have seen the examples of, you can see the examples of rational number yourself. You can take different types, different rational numbers, like you can take 10 upon 3. So of course 10 upon 3 is a rational number itself, because we have already written it in the form of p by q, which is a rational number. So we are not going to show that whether it is a rational number or not. It fits to our definition of p by q. So we don't need to prove it further. But let's see how the decimal representation of this is. We can prove a number as rational or irrational based on these two definition also. That if the decimal representation comes as non-terminating, non-repeating, then it is an irrational number. And if the decimal representation of a number comes as terminating, then it is a rational number. And if it comes as non-terminating but repeating digits, then also it is a rational number. Here we want to see the decimal representation of 10 by 3. How much it would be? It is 10.3333 and it would continue, non-terminating. So it is a non-terminating, but digits are repeating. So this is a rational number. So you can see yourself different examples from your book. Also, you can see different examples. You will see that in case of rational number, either it is terminating, and if it is not terminating, then it is repeating digits. And rational number that we have seen, in the rational number you have seen that root 2 will have a non-terminating and non-repeating decimal representation. We have seen 1.414 and further. You can see further root 3 will also have non-terminating, non-repeating decimal representation, root 5, and these all have non-repeating and non-terminating decimal representation. These all are irrational number. And one very important example of irrational number is pi. Pi is an irrational number also, because pi does not have a terminating decimal representation, or if non-terminating, then repeating decimal representation, right? Whatever we take the value during solving the question, during solving the problems, are only approximation of pi. Again, you can do the Google once and find out the value of pi. It would be non-terminating. It can give you up to a certain number of digits only, but which is an approximation only, not the exact value of pi. During the solving of problems, we can take 3.14 or 22/7, whatever you take. But remember that these are only approximation, not the exact value. So we should not get confused. Like when we say that pi is a irrational number, sometimes like kids come with like pi is the value of 22/7, then how can it be irrational number? Because the value itself is in the form of p by q. But no, that is not the exact value of pi. The value of pi is these are the approximation of pi, right? See, here an important thing is, can irrational number be represented on the number line? So actually, see what the number line we normally see. This is the number line, and here it is 0. This side is positive number and this side is negative number. Actually, see, this number line is what we call this number line. This is real number line. You don't call this line as rational number line or irrational number line or whole number line. This is what real number line. And see, the rational number and irrational number, these both are real number. These are not so that these are imaginary number. कि ऐसा नहीं होता है. नहीं, pi is a real number. root 2 is a real number. They exist very clearly. So these all are real numbers. No. So if rational number as well irrational number are real number, then they can be represented on the number line also. All the number that we have read till now, and you are not going to read non-real, which are imaginary number in your class 9 syllabus, I think so. So you are going to read only the real numbers. And this is the number system chapter. So you are going to read all the types of number that you have to study in your class 9 here in this chapter itself. So we don't have to study the imaginary numbers here, and the rational number and irrational number and all the numbers that we have seen earlier, natural number, integers, whole numbers, rational number, irrational number, these all are real numbers. So when we say that they are real numbers, then yes, they can be represented on the number line also. Let's see some of the examples. You can think so ki, they don't have a they don't have a repeating, or they don't have the terminating decimal representation, then how can we represent them on the number line? But they all are real, they all exist. So in that case, they can be represented, they should be represented on the number line, right? See, actually, every point on a number line represent a number, rational or irrational. You can categorize every point on the basis of rational or irrational. Whatever the type of number that we have seen prior to rational number are rational number also, like integers, whole numbers, natural number. These all are under the rational number only. So we would see some examples of irrational number and how this irrational number can be represented on the number line itself. See, so we have to do some little bit of construction here, and see, to teach construction through online is little difficult actually, but still I would do my best as much as possible. But still, see, when you are doing the construction, I have to see that how you are holding your compass, how you are drawing an arc, how much pressure you are putting when you are placing the compass in your notebook on. These things need to be noted, but I'll request you try your best, and you can see some others video also where these things are more refined actually, ki how you can do the construction through your compass. I don't have any other videos. You can see some other lecturers video on YouTube. So what we would see here, let's try to represent root 2, which is an irrational number, on the number line. We would try to represent root 2 on the number line C. So what the concept we would use to represent root 2 on the number line? See, this is a right angled triangle. If the length of the base is 1 unit and the perpendicular length is also 1 unit, the length of this hypotenuse will come as root 2. You can find out through Pythagoras theorem. I am not going to that. So if base is 1 unit, hypotenuse is also 1 unit, then perpendicular length is also 1 unit, then the length of the hypotenuse will come as root 2. So this is our number line. This is 0. And this is through your compass, you will cut from here to here 1 centimeter. You can cut. If you have to draw the square root 2 centimeter. So this is suppose 1 unit, and here you have drawn a perpendicular sending to this point. Let's consider this point as A. So I hope you all know that how to draw a perpendicular on a particular point. See, this is like this. We have drawn a perpendicular. Now we'll construct and we'll cut an arc of this same length, like this to this. We have cut this is. So this is also nothing but 1 unit. And this length is, if you have to just join them, and the length of this is root 2. So now we know the how much is root 2. So we can cut the same length arc on this your number line also. From this to this, again you will measure this and will cut an arc from point O to this, suppose this. So this point, let's consider this point as B. So OA is nothing but root 2. This length is nothing but root 2, right? In the same fashion, we can construct the root 3 also. This is another number line 0. Just now we have drawn B. So if you have to construct, you have to find out the another point of the length root 3. Then first of all you'll do up to this construction on this, and now we have this is b, which is nothing but root 2. So again you can draw a perpendicular from here to here on point b. You can construct a perpendicular on point b. So again on this right angle triangle, if suppose the base is root 2 and the height is 1, then the length of the hypotenuse will be root 3. We are going to use the same concept here. The base is root 2. How? From earlier construction. And then we would construct a point BP of the length 1 unit, and you can join OP. Then the length of OP will be what? Root 3. You can measure this OP through your compass and cut the same on your number line. Let's suppose this is point Q. So OQ is how much? OQ is root 3. In this way, you can construct root 4. Root 4 is nothing but 2, root 5, root 6, root 7, root 8 itself. So in this way, we can represent these irrational numbers on number line also. So all the irrational number, please remember, all every irrational number can be represented on the number line. All rational number, all irrational number can be represented on the number line. There is no restriction that we cannot represent them on the number line, right? We will see some question from your NCERT. So let's quickly see some question from this NCERT textbook from the topic we have covered till now. So this is exercise 1.2. Actually, I wanted to complete this number system in this session, but it won't be possible to cover in this session. We would complete up to 1.2 and we'd require one more session to do some more operation on irrational numbers. So this is 1.2, and it is very important that you are doing all the question of your textbook, whether you have NCERT textbook or some other writer's textbook, but please complete each question of your textbook. I am trying to cover all the concepts here, that it is, I am trying that nothing is left, but still it may happen that from compared to other textbook, something is left. So I'll request you that you go through your book. Somewhere in the book itself, it must be discussed about how to solve those questions. So this is 1.2c. We have to identify true and false. Every irrational number is a rational number. I have told it many times that yes, every rational number as well as irrational number are real number. Why? Because they can be represented on the number line. Just now we had seen also that root 2, we represented root 2 on the number line, root 3 on the number line. So yes, every rational number as well as every irrational number are real number, right? Every point on the number line is of the form of root m, where m is a natural number. Can you say no? It is not true, because negative numbers -1, -2 and c other numbers also between cannot be represented in the form of root m. Negative numbers are not the square root of a number, right? So this is false. Every real number is an irrational number. No, real number is a rational or irrational. So every real number is not, every real number is an irrational number is not true. It can be rational, it can be irrational also. So this is again false, right? See, are the square root of all positive numbers, positive integers irrational? Are the square root of, you can identify yourself, I don't need to go into that because we have earlier covered it. So how root 5 can be represented on the number line? I have told you. We represented root 3 using root 2. From root 2, we represented root 3. So from root 3, you can represent 4. Actually, we don't need to go up to 4. You can directly cut 1, 2. 1, 2. So this is root 4. This is root 4. Then again, if you have to represent root 5, what the concept you can use? You can use this. If this is root 4, which is nothing but 2, and this is 1, then this length would be nothing but root 5. So on 2, you can construct a perpendicular, cut an arc of length 1, and this length will be nothing but root 5, right? And this, see, the next is classroom activity. This is a very good one. You should not leave any questions here. To clear your doubt, we need to do these activities also. So you can do it yourself. See, the NCERT book is available online also. So if you don't have the book, you can download it online chapter by chapter. You can download all the chapters in one go also. So you can do this activity from this book and understand these things more easily. Again, I will request you that whatever we are covering here should be very clear in your mind. If something is left as a doubt, will be not good for us. And again, I'll request to do your study very seriously and cover everything from your book. So thank you for watching this video. In the next video, that will be in session 3 on number system. I'll try to complete the number system. Thank you all. Hare Krishna.